It has not been often that a new technology has been as quickly and widely embraced as the new upscaling technologies like FSR and DLSS. The purpose of these technologies is to increase the game's performance with minimal visual quality loss, which is very important nowadays with the standardization of 4K resolutions and the ever-growing visual quality of new games. But as always, with new technologies, there are of course bugs, issues, and this time, most importantly of all, there's a lot of misinformation about them. And this is a real shame because from a perspective as a game developer, I think upscalers are one of the best techniques that have happened to games in the past few years, both for performance and visual fidelity, but only with a small disclaimer, if used correctly. In this video, I'd like to really explain how upscalers work step by step and try to get rid of some of the misinformation and even try to explain the difficulties that developers face when trying to implement these techniques. On a side note, this may get a bit technical, so for those who want the Sesame Street explanation, well, here it is. Hey Kermit!
Hi Dom, how awesome to be on the Naked Dev Show!
It's great to have you, Kermit. Will you help me explain upscalers? You see this huge monitor. It has many colored lights on it. These lights are called pixels. Do you see the pixels? This smaller screen has way less pixels, so it takes a lot less power.
But then why don't you just use this big monitor, but then with less pixels in it? That way you have a big screen and still don't need much power.
Very smart, Kermit. You are right, of course. A big monitor with a few lights in it will take a lot less power, but it will look ugly as well.
Oh, so now we need an upscaler.
Yes, this is indeed why we need an upscaler. The upscalers is a very unique algorithm. To make it work, we need the three magic words: lock, shake, magic. Yay! First, we lock every pixel that isn't moving. That way, we get the outlines of everything that is on screen. Then, we shake everything.
Really?
Yeah, really, Kermit. By shaking everything, we blend each pixel with its adjoining neighbors. This way we get a nice looking but very blurry looking image. Lastly, we apply the magic to blend the lock and shake together into something that looks as if we used the huge monitor with many pixels.
Wow! Is it that easy?
No, Kermit, of course not. Of course it's not easy, but the theory is sound. Lowering the rendering resolution of a game, it takes less processing power to render. And to make the upscaler work, all the game engine needs is to pass the rendering textures, aka buffers, in low resolution to the upscaler. Then the upscaler will do its magic and export one upscaled image back into the rendering pipeline of the game engine. The first buffer is called the color buffer. This is the graphical visualization of everything that is currently visible inside GameView. The second buffer is called the depth buffer. This is the graphical representation of how far visible objects are within view. In this case, pure black is closest by, while pure white is furthest away. And the last buffer we need is called the motion vector buffer. This is a fun one. It's a graphical representation of objects that are moving and how fast they are moving. So black means there's no movement and all the colors are up, down, left and right. And how more intense the color is, how faster the object is moving. And the colors can also be combined to indicate that the object is moving up and to the left, for example. Almost all modern game engines use these three buffers, and also others, but we don't need them for upscaling. However, developers often make mistakes when using these render buffers. The issue is that not always all objects will add to these three buffers. Some modern techniques for vegetation, for example, will not add their movement, like waving grass, to the motion vector buffer. In this case, the upscaler doesn't know that the object is actually moving, and so the upscaled image will have visual artifacts. I see this happen often in the implementations of my upscaling plugins for Unity, as Many of the vegetation plugins don't add their movement to the motion vector buffer. In short, all visible objects in the game should always be added to the three buffers, the color, the depth, and the motion vector buffers, or the visual fidelity of the upscaler will be a lot less. Another fun example is that sometimes developers use invisible objects for certain effects, like to bend hair around a sphere or blend vegetation around a character so that the character moves away the grass when it walks through it. And while the object itself is not rendered in the color buffer, as it's invisible, it often still is being rendered in the depth or the motion vector buffer, which results for very interesting upscaling results. Another thing I often see hardcore gamers do is they swap out the different versions of DLSS in their game. And some versions of DLSS work better depending on the game. Being able to swap out the DLL as a consumer is pretty neat. With FSR, gamers often complain they can't do this, and there's a very simple reason for this. DLSS is not open source. Nvidia only hands out these very protected library files called DLLs to work with. So each developer will have to build some kind of bridge between their game engine and the hidden and highly protected C++ code inside the DLLL. FSR 3, however, is fully open sourced, and each developer would be a fool to create a DLL and then also have to create a bridge between their game engine and the highly protected C++ code inside the DLL. And because the FSR source code is publicly downloadable on the internet, there's no need to protect it to make things overly complex, and even worse, because DLLs are Windows only file type. This means that DLSS will never work on any other platform than Windows. Because every developer is free to do whatever they want with the FSR source code, they can fully integrate it into their own game engine and then export it to every platform. So yes, it can be a bit of a bummer that gamers can switch to other versions of FSR in their favorite games. But on the plus side, they can enjoy their games with FSR on the Xbox, the PlayStation, and the Switch. Seriously, FSR can run on almost every platform, even Android and iOS. And to finish with the biggest misconception about upscalers, the actual performance gain you can get with them. How many videos are there on YouTube comparing the performance of DLSS against FSR against Intel XeSS? Which makes no sense at all because it isn't the upscaler that gives the performance boost. The only thing giving the performance boost is lowering the rendering resolution of your game. The upscalers only make the ugly low resolution rendering look good again. So there's absolutely no reason to actually compare their performance against each other. Nvidia and AMD both highly recommend developers to implement the same quality settings in their games. They are called quality, balanced, performance, and ultra performance. FSR and DLSS use the same dividing number to lower the screen resolution. This means that both tools will give you very similar performance boosts. The reason this misconception is even out there, I think, is because Intel messed up with their upscaler called XeSS. Their recommended quality settings don't match those of Nvidia and AMD, as you can see, meaning that the same quality settings in name will give different performance and different visual quality, as it's not a true nor fair comparison. Now, as a game developer, I really dig these upscaling algorithms, which is also why I created the assets for Unity in the first place. So all the developers that are using Unity can implement these technologies in their games and improve their performance and visual quality. And my closing argument for always enabling upscalers in every game is that one of the epic side effects of all upscalers is that they remove those ugly jagged edges from the highest quality settings of the upscaler. Often gives a bit of extra performance, and it will also make your game look a lot better if the game has implemented FSR or DLSS correctly. Okay, sorry. I hope you're still with me. This video was quite technical and difficult, also for me to explain. And if you want to know more about upscalers, don't hesitate to ask any questions in the comments. And I'm really sorry if this video got a bit too techy for your taste. I'll make it up to you next week. See you then.